Tut02 number 11. Do you know that whenever you want to actually find asymptotes, right, there are just two steps you need to do, no? Step 1 to finding asymptotes is like this, no? Step 1, you want to put the denominator to 0. If you put the denominator to 0, you get x equals to 0 or x equals to 1. So then you check the numerator, no? When x is 0, will the numerator be 0? Nope. When x is 1, will the numerator be 1? Nope. If that's the case, then these are the vertical asymptotes. Okay. Then to look for the other kind of asymptotes, right? The other asymptotes is, what you do is you check for this. As x goes to infinity, you can calculate the limits using whatever method you know of, whether from chapter 1 or using L'Hopital. If you calculate the limit, and this gives you, in this case, right, half. That tells you that y equals to half is a now, apart from checking infinity, right, you must also check the other infinity, when x goes towards. They need not always give you the same limit, both left and right limits as x goes to infinity and negative infinity need not be the same value. So it's always good habit to check both sides. But in this case, if you do your calculation using all the method you know of, and again, it means y equals to half stop. So in this question, the function obviously has 2 vertical and 1 horizontal. Let's check again. A horizontal at y equals to half, and vertical at x equals 0 and 1. So for the reason, yesterday Ethan was eagerly telling the class, C. Yeah. So 11 is indeed C. C for can. 可以 boleh Okay, question, anybody? Okay, Yen is doing some yoga, is it? Yen, is it? Okay. Okay, let's do number 12. Okay, sorry. And the boys behind, Ashad, got something to tell teacher? Okay. Oh, really? Funny, huh?
Your voice also sounds very good. Yeah. I love Mr. You're like a solid 10 out of 10. Solid 10.
Okay, number 12. Now, there are various ways to do number 12. One approach of doing number 12 is to rewrite number 12 as like this. As ln of and then very quickly you recognize that it matches the definition of the differentiation of the function ln of x evaluated at x equals to 2.
Wait, the paper difficulty is like this?
Yeah. This is going to be not so difficult.
What is so hard?
So the answer to part A in this case is again. Oh, you're doing the assignment, is it?
Yeah.
Okay. You're all ready, is it?
Ready.
Monday. 04 has already gone through assignment with me this morning. 04. 04 is slightly ahead because they didn't miss any lesson. Some of the timetable jump in the end. They have more lessons than you. I know that, yeah. I'll tell them later.
The gradient is positive.
For the next question, you want to rewrite this thing as I have jumped a little bit in my arithmetic. I've jumped a little bit in my arithmetic. So this is 2x, okay, 2x here. And this gives you 4 times 1 square. 1 minus cosine square is right. So sine square. You know what I mean? The sine square 2x, right? Maybe I rewrite again. I write one more step. This gives you limit x goes towards 0 of sine over x square. And then just go to this. Yeah, reason I introduced 4. Can you see it's a 4. Ethan's center is 4. 2 square, right? Then put back a 4 here. Okay. Is there any other way to do this question, right? Maybe this is about one of the best way then. Yeah. You can use L'Hopital if you want to, no? Yeah, you can use L'Hopital. Okay. For the next question, when x goes with 0, right? When x goes 0, the numerator is 0, the denominator is 0, right? So that favors the use of the L'Hopital. You can use L'Hopital for this one. If you don't use L'Hopital, I think it's also possible. No? I think it's possible to use. Okay. Anyway, let's use L'Hopital. The numerator, when you differentiated it, is ex plus x e power x over minus ex. So this gives you limit x goes towards 0 of 1 plus x over minus 1. So this is going to be negative 1. Okay, for part D, right? For part D, you will realize that it has the indeterminate form. Right? So therefore, we're going to use the L'Hopital. By the way, when you apply the L'Hopital's rule, it is always good habit to say that you're applying the L'Hopital's rule. No? Right, it's always good habit to state the theorem you're using. So for the next question, L'Hopital rule is possible. If you do one round of differentiation, it becomes 100 x to the 99. And you go on forever, not forever.
100 factorial over.
Brilliant.
100 factorial.
Fun fact, I once tried to calculate 100 factorial by hand, it did not end well.
Yeah, I can't calculate 100 factorial. Which one? There's a danger though, because this one is going to be very large, so if this, which is e power minus x, becomes 0, you can't tell. Extremely large times 0. What's 0 times extremely large? 0 times infinity is not defined. What direction? X bar.这是 exponential， 这是一起的，你不会这样子把它一起出来，这好像1 square， 你不能把它1带出来，没人带出来。1 square 是1，this one is 1 square 1 square please. Sorry about bring up, become bring up. Okay, for the next question, because you got very good eyesight, you can guess that this question is going to be 0. No? Why is it so? Because if x is extremely large, this number is as good as x, you know. But in any case, let's do it the proper way. This gives you limit. Because ln is continuous, I can potentially do this now. One over. And this gives you ln of 1, which is 0. Yes, I heard a question.
The question again is positive infinity. Why can't you just say infinity?
Can just.
It's not plus infinity. Yeah, but why plus infinity?
Redundant. Yeah, redundant. Yeah, right. So Jethro is upset with this redundancy.
Extra thing I need to look at.
Yeah, he's upset now. Say in exam, teacher, please don't do this.
It's a waste of my time to get.
Wow. Okay, part F. Let's invite someone to do part F. Anyone wants to do part F? Is there any part F taker? Okay, Ting Wei suggested she herself. Ting Wei, just try. Part F. I have faith in you. Tin, go. Part F. Right higher up, so that people behind it. Thank you. Let me go around to see the extent of the tutorial that you have done. You know, especially the boys behind. You know. Asha, your whole group here finished tutorial. Yeah. Sure.
What is this?
The numerator differentiate is product. The numerator is differentiate as minus e power. Right.
What are you doing?
The marker guided. The marker is quite thin. Let me give you a better marker. Okay, I give you a starting line. Maybe you write here. The log of
these are the laws.
Then you get that.
use that to help us. Because the power can be brought down, you see. The power can be brought down as tangent pi x. And I give you another hint. Can I give you another hint?
Yes.
You try to create a scenario where L'Hopital's rule is applicable. Try to rewrite so that you can use the L'Hopital's rule by Ting Wei suggest use L'Hopital's rule. Okay, Ting Wei, what is below here? Because it's continuous. Tangent you bring to the denominator become. Yeah, you're right. You're right. Yeah, Ting Wei was telling me here that she said this. Yeah, she's right. You're right. Yeah. So now the condition favors the use of the L'Hopital's rule, Ting Wei, because when x goes towards 1, you get negative infinity and infinity. I'm talking nonsense. Balik. I'm talking about 0 and 0. Right, because when x goes towards 1, this will be 0 and this will be 0. So you use now apply L'Hopital's rule to the power.
How to differentiate cotangent as well?
Okay, differentiate cotangent is minus cosecant square. You can bring up the limit as like that because exponential is a continuous function. Now I can apply the L'Hopital's rule on the green color. Yeah, negative cosecant square. Negative cosecant square. Negative cosecant square.
Oh, right.
Right. Yeah.
Yeah, but you know that was the last thing I
What's the quotient rule? You just differentiate them. You can bring a limit out first. You can bring a limit out first. Good. Okay. You can bring out a limit first.
Why is it so goofy?
Just focus back.
Stop.
Yeah.
Okay,
Yeah, but just write down. Then write down something first. Yeah, okay, then stop the okay, from there. You can write higher up. Yeah, right. Differentiate this one. Differentiate this one, right? Don't push it. Go down. You need to differentiate the numerator by itself. Yeah, by itself. Okay, then this gives you minus cosecant squared, yeah. So this gives you minus half.
The second is 1/5.
Minus 1. When you differentiate this one, this is strong minus. Whereas after differentiating it, you got differentiate minus x. Right? It is this one take over. Plus, right? Plus. Right? Plus. Because 1/5 becomes 2. Yeah, 5. Yeah, right. Wait. I think the means no. Debate 5 only, sorry. Right. My last time is wrong, yeah. I'm going to make a correction. Yeah, teammate did rightly, I did wrongly. Yeah, so embarrassing, it's so embarrassing. I'm going to make a correction, Okay, I made a mistake. Okay. It's a good question, this one, part F. Okay, any questions to raise? Aditi, you said you tried this way, it didn't work. You were quite close. And the saying is, so near yet, right? Okay, then if you're done with part F, right? Part F. With part F, so yes, let's think first. Then you can try part G. G is too simple, right? But you got to be very careful, how you present G. You don't just write the answer as 1, and then think that you get full marks. You won't, You have to actually pretend that it's a hard question.
Pretend bozo.
You want to do it like this. You can do it like this, but of course there are other ways of doing it. Some people say factorization and all kind of method. You can also use repeater. Actually, factorization is probably easier.
Yeah.
For those who have done it as a factorization, actually you find that it's actually easier.
I forgot the limit.
Yes, make it as potentially yes. Yeah. Some people like Kalash, he has a different way, which is much easier. It's true. Yeah, right. So you can do by factorization or breaking down into 2 fractions. Kalash method is quite close to factorization actually. It's quite the same as factorization. Akash, you agree? Akash? Ashad, not Ashad. Ashad, you agree? Not? Agree? Not? You agree? Yeah, you're right. Yeah. Okay, I made a mistake. Will you point out to me?
Mission fail.
Actually, I was silly. I was totally wrong. I thought it's infinity. I cannot retract. Thank you, Wenyu, for pointing out. I'm so embarrassed. What happened to me today, man?
Mission fail.
Mission fail. I'm totally wrong. I think I got to do it this way. Today, I have a malfunction.
Did you not get enough sleep?
I did get enough sleep, you know, it's not about sleep, it's about too happy. It's always nice to be in this class. Hear a lot of silly stories. Yep. No, can because it's 0 over 0, right? Yes, can use L'Hopital also. L'Hopital will work just as well. Asha, what method do you use? G, what method do you use? G? What do you use? Yeah, you can L'Hopital it. Yeah, straight. No, because this technique is only good when S goes to infinity. If S not going to infinity, it doesn't work. Thank you, Wenyu, for pointing out. No, I just assume. Yeah, I cannot assume. I didn't read the question carefully. My bad. Yitong, you're telling Rayson some math question, right? Say yes. Yeah, you're right. Okay, so. Okay. Okay, question 13. Okay, Rayson, for having taken your lunch and therefore energetic, take us through 13, option 1, true or false? Right. Is it false or is it not true? Yeah, it's false. You're right. It's false. It's false. Why is it false? Okay. Yeah. One way of saying this is there isn't a change in sign. That's what. Or actually, maybe this is a wrong conclusion. The conclusion ought to be what?
F prime.
Right. So therefore. Okay, F has a 0 over this interval 4 to 7. Rayson, do you or do you not agree? You agree? Yes, it's true. Rayson again. Yep. Yes, so. And what theorem do you use?
No, MBT.
The MBT says that there will be a gradient which is equals to gradient of the second line.
Gradient of the straight line between the 2 points.
Right, second line. Sure. Personally, I do not collect water from water cooler. No. I don't, you know. I find water cooler because it's in the open, right? And near the garden, right? Sometimes in the night, the creatures, the insects also feed on the water there. It's true. I've seen my own life before. Not in the school. Because the insects also need water. So they also do the water cooler. They cannot press the thing, but they can just lick from the nozzle. I bring bottled water to school every day. You know, the bottled water is not very expensive. No? 1 carton of 24 ice mountain cost me $7.50. $7.50. 1 carton 24 bottles. Wow. 1 carton of 24 ice mountain, right? Cost me $7.50. Wow.
But it's an environmental concern because of all the packaging.
Yeah, you're right.
So if you have your own water boiler, you can just like.
Your own, but they have boiler for you, right? They have a boiler for you. Yeah. Because the water cooler, sometimes I get very worried. Okay. So the answer to this one, according to Rayson, is again C.
Why
C stands for can, 可以, boleh.
The test also have a lot of answers C.
I'll tell you after the test.
After the test. Wasted.
Okay. This question must go to.
Oh my god.
I don't see Kai Fan today. Where? Oh, okay. Okay. Okay, maybe Kaita, just start the ball rolling. Okay, class, let's hear from him. Okay, to find the inflection point, what would you do first? What do you do first? You put those two, and then you identify the possible candidates, which are A, B, and well, but then that's not good enough, Kaita. Okay, don't worry. Kailash, could you please tell us how do you pick your choices A, B, C? Oh, can I ask Kailash more? Okay, Kaita, is there anyone whom you want to pick to help you? Okay, he's saying Zhen Hong. He pointed to Zhen Hong. How do you pick whether A, B, or C, or all of them? Look for this. Okay, Zhen Hong, for the point A, do you think f dot prime have a change in sign? If you use a number before A and a number after A, yes, you're right. How about B? Will there be a change in sign for B? No. And for C? Therefore, the answer is at A and C. Okay, Kaita, I hope that is the way to do it. You don't remember how they did it? The change in sign. Let's look for a change in sign. Oh no. Oh, Chris. Howard, what's the story behind and share with us? Tell us the story, come. I'm sure you have
What's the behind there?
What is that? So what is a version of the MBT? Howard, what's a version of the MBT? What does it represent? Okay. Yes, you're right. You're right. Okay, let's do part B. Okay, Howard is volunteering, right? Howard, B part 1. You say can, right? It cannot, because R is open interval. Right, so for part 1, right, it is continuous on the entire real line. Entire real line is an open interval, and because of this, we cannot invoke the EBT. Okay?
No.
Okay, Ting Wei cannot control herself, yeah, Ting Wei. Okay, part 2. Find the interval where G is increasing and interval where G is decreasing. How do you do such a question? Let's see. Okay. Mean. How do you look for interval where G is increasing? What do you do? Right, you do G prime, and what do you do about G prime? You want it to be? Right now. and then this gives you x. So therefore, G is increasing. Okay, let's hear from Min. Min, say. We can include 1 in this case, no? Like, apart from 1, the grade is all positive, is it? And then correspondingly, mean continue, G is decreasing on what interval? Right. We also include 1, the other direction. Okay, Martin, are you ready for part 3? Yo, yes, Jethro.
If infinity is a closed interval, then why is R open?
When you say it.
Because I remember you mentioned something about infinity.
No, like this, because like this. If your interval is like this, say minus 5. Okay, say for example, right? Okay, this interval like that is need to be closed. This is closed because the flip side is open. You know what I'm saying? So last time I talked about this. This is closed, but from minus infinity to infinity, the whole thing right is open. Yeah. So I think it's very fuzzy, because you get very upset with closed and open interval, the special cases. Okay, we were talking about. It's open. I did. Page 28, page 28. The note says, is it? Okay. Let me refer to the notes. There's a point raised. Let me page 28. 28. Okay. Maybe I am wrong in this. No? Okay. Jethro raised out objections and he refers to the notes. No. Right. If I get correctly, minus infinity to infinity is need to be both closed and open. If I get right. But anyway, he's right. The notes recorded now on page 128 that minus infinity to infinity is open. So therefore, I cannot use that as a reason. Can I retract? It is because I'm bounded. Okay, let's change. I'm bounded. Okay, thank you for raising up. No, I should change. Because minus infinity to infinity is unbounded. Hey, thank you for raising up, no? Thank you, Jethro. Thank you. Unbounded. I'm not use the word open bounded, because it's very strange, no? Just like the class. What's the opposite of tuck in? I don't think so, no. You can say you didn't tuck in your shirt, no. You don't say tuck out, no. Because tuck have the meaning of sandwiching, right now. Right, you don't say tuck out, no. Actually, you only say you don't tuck. You need tuck in your shirt. That's all. You know what I mean? I think. Who is your language teacher? Miss Das. That's the best teacher to consult. Ask her, no. What's the opposite of tuck in? Consult her, lah. I don't think it's called tuck out, you know. What's the opposite of tuck in? I don't think I can say tuck out, no. Because tuck has a meaning of sandwiching between things. So if we say you did not tuck in, that's false. Because say tuck out. I'm not use this phrase like that, but I will always say you didn't tuck in your shit. That's all I say. I will not say why tuck up. You know, it's wrong. You know, yeah, it's wrong. Okay, alright. Back to this. So class, for part 1, right? So bear in mind, it is because it is unbounded.
So you cannot say that it's open.
According to the page 128, right? It says it's closed. I will also talk to my colleagues about this. That one may be both open and closed. It's a special case, no? Yeah.
Wait, that doesn't satisfy both conditions or does it or none of them?
Say again.
Wait, so that means if it's open and closed, then
Okay. I will get a consensus with my colleague. According to the notes, H128 that is pointed out by them, minus infinity to infinity is still be closed. Okay. So, yeah, about the Spencer ones. Okay. Yes. Okay. Let's come back to part 2. Shh. This is always a point of contention, you know. Like, let me ask you again. Let me ask you, okay. If your graph that's like this, the graph that's like this, okay, like this, for example, like this, this graph is y equals to x minus 1 cubed. Tell me the interval for which this function is increasing. Do you? Okay. Sorry. I think I should change the equation. Thank you for this. Power 2. Okay. Yep. Tell me the interval for which this function is increasing. Shh. Do you say increasing on this interval, or do you say increasing on this interval? Which interval? Yeah, second one, you know. Because only at the point it may experience a zero gradient, other than that, don't have. And it fit in the definition of increasing because starting from this point and to the right, the value keep going up. Yeah.
So for the intervals where this function is increasing and decreasing, both increase the one.
Yes. Where were we? Here. The graph is it? Yeah, on the graph is it? Okay, let's draw the graph first. Shh. Chen Hui, right? Chen Hui wants to draw the graph first. So Chen Hui, just go ahead. Chen Hui wants to draw the graph for us, the graph of G.
It's not accurate, by the way. I checked with
No worries. Just try.
I checked with the graphic.
Calculator, is it?
But it's a bit inaccurate.
No worries.
The actual one is like.
Okay, thank you. Chen Hui, you didn't check the x-intercept carefully. But it's okay. Yeah, quite close, it's okay. Sure, thanks. The shape of the graph is correct. Anyway, the shape of the graph is correct. Because you were very attentive to this point, and you, as an oversight, it's okay, small oversight. Okay, so Chen Hui says the graph, okay? Right. Okay. Now let me retake this now. The interval for which it is increasing and decreasing, as pointed out by some of you, one is double counted. It's just like that. Okay. One is included in the increasing as well as the decreasing. And then in this question, you asked to find the absolute. Okay, in this case, you only have absolute minimum. So you say that G attains. Sure.
Wait, so which graph is correct?
The one there.
That one.
Yeah, that one.
The one in blue or the one in black?
Blue.
So this one's wrong.
Just only a big difference. Maybe have one try this one.
I was gonna use this.
Jaira, can you Google and check now? Minus infinity to infinity, is it considered open or closed or both? Yeah, I think, yeah. Yeah, is it considered being closed or is it open? I think it's both. I think, okay.
Because it doesn't have a complement.
Complement is empty set.
Oh, then it's an empty set of
No, that's fine. That's a very special case. Okay, let's press on. Attains an absolute minimum at x equals to 1 since g is decreasing for x before 1 and g is increasing for x more than 1. Absolute minimum therefore is equals to g of 1, and in this case it goes to minus 3. That's absolute minimum. That's for part 3.
X less than or equals to?
Because you're talking about okay, can. At first I thought one grade. Okay, sure. Thank you. Yu Tong pointed out I should really put yeah, she's right. Okay, part 4. Okay, De Yun. Part 4. De Yun. Okay, what is your take on part 4? Is it yes? Yeah, it's correct. Yes. Yeah, it's entire real line, It's entire real line. But how do we know, Because if you look carefully, right, the g prime x, which is equals to the g prime is 4x cubed minus 4 is an increasing function. Is an increasing function over this interval. And if the gradient increases,